Hi, people, folks, lads, whoever. This is the quadratic functions. This is the fourth video. We're going to be looking at forming quadratic equations or quadratic functions, we like to call them, on page 146 and 147 of your book. So, as I was saying to you before, we've got two types of quadratic equations. We've got they're all parabola shaped, which means they're either U-shaped or N-shaped. That's a parabola. And they're either positive or negative. So positive meaning that it makes this kind of smiley face, which is we call U-shaped, and negative where it makes this N shape. We call that negative. Sorry, that's positive, and this is negative. I think I meant to say the opposite. Then we know that these points just here, where it cuts the x-axis, are called our roots. Now we know that quadratic equations have different types of roots. They could be negative and positive. They could be both negative. They could be both positive, where it cuts the x-axis like that. Just draw that in there for you so you can see it. So these roots are both positive, and even sometimes they have equations where both the roots are the same. So this only cuts the x-axis in one spot. Only touch the x-axis in one spot. So that's where its root exists. Now, to form a quadratic equation, I think you need to review how to find the roots of a quadratic equation, because that's what we're always trying to find, the roots of a quadratic equation. So if I give you this question here, first of all, you'd look at that and you say, well, that's a type 1 quadratic equation. So I can factorize that very easily. Open two brackets, put an x at the start of each of them. What are the factors of 10? That give me 7. Well, that's got to be 5 and 2. This is a positive, and that's a positive, so the signs have to be the same. So then, what we always did is we split this into two halves. And I told you that x plus 2 was equal to 0, then x must be equal to minus 2. Then on this side we said x plus 5 is equal to 0, then x must be equal to minus 5, because we subtract 5 from both sides. I said to you all along, okay, we figured out all along we were doing our sketching that these are the roots. So one set of roots exists for this equation at minus 2 and 0, and another set of roots, or not a root, exists for this equation at minus 5 and 0. So this quadratic equation is both on the negative side. So we'll sketch this down really quickly, really roughly. So it looks something like this, maybe not quite like that. Probably looks a little bit more like this, because of course if we look at our equation, original equation, the 10, or the number without an x, is always the y-intercept. So this intercepts at 0, 10, and it's got roots of minus 2, 0, and minus 5, 0, just there and there. Now, what forming quadratic equations will ask you to do is to work backwards. They're going to give you the roots, and they're going to ask you to go in this direction, back up, to form the quadratic equation. So, this is how your question may be given to you. So now we know what the answer to this equation is, this fella here, but what we're going to do is we're going to work backwards. So, we know that if the roots exist at minus 5 and 0, and minus 2 and 0, just there, and there, then we know that x is equal to minus 5. I'm just going to rearrange it slightly, so that's minus 5 there. And we also know that x is equal to minus 2. Now, we also know then that if we work backwards, then x plus 5 is equal to 0, and x plus 2 is equal to 0. We bring those two together and we multiply them. X plus 5 by x plus 2 is equal to 0. One number by another must be equal to 0. If they're both equal to 0, then they must be equal to 0 if you multiply them. Now all we have to do is you got to just multiply these out. So you just say x by the second bracket, so the first term by the second bracket, plus the second term by the second bracket. Multiply that out and you'll get an answer of, I'm running out of space here, but I should be able to fit it, of x squared plus 7x plus 10 when you simplify that out being equal to 0.